All right, tutorial. So sometimes I do have a tutorial sections on Monday or Friday or Thursday, depends on how many students asking me. So this is a tutorial section for your homework. So if you need any questions, let me know. It's recorded. Perfect. And again, sorry for last week, I didn't record the whole entire Zoom meeting. So if I forgot to recording it, let me know. How do you know that? Is on the left side of the corner that is the recording little red dot on it. It's telling you that it's recording. If you didn't see that little recording dot, just tell me, hey David, you have not you didn't record this video. So that this Zoom meeting. So no. So let's, okay, 6.2, question 17. Yep, I do have that in here. Anyone have any questions besides 17 on 6.2? Okay. And you can, don't be shy, because this is again, I'll help you more on this one because it's, all right. So this is 6.2, question 17. Henry, I just, again, this is just helping you. So this is question 17. If you look at the watch, if you watch this on question 17, they will ask you to use this formula, which is, where's the formula at? They will call you to use this trigonometric identity formulas to find your sine, your cosine, and your tangent, and all those things they're asking for. You do not need to do so. There's only one formula you need to know right now is the complementary angles. Sine and cosine is complementary angles, co-functions of complementary angles each other. What does that mean is that if you add the two angles out, the angle should be a total of 90 degrees. So sine and cosine will have one of them, tangent and cotangent is another one, and secant and cosecant is that one. So example is secant 25 degree is the same thing as cosecant 65 degree, because if you add these two angles out, it becomes 90 degrees. So how do we do question 17 here? You will do the SOHCAHTOA in this case, the easiest way. So this secant theta is 5, so we can find cosecant theta easily because secant and cosecant, they are reciprocal to each other. So you just need to reciprocal the value 5. So in this case, it's 1/5. And in order for you to do the rest of this, I will suggest you to use the right triangle. So to do question 17, since it's given us that cosine theta in this case is 1/5, so that means that 1 is your adjacent because it's cosine, and 5 in this case is your hypotenuse. So you just need to figure out the opposite here. So you have to use Pythagorean theorem to do this. So in this case, I just say b. So a squared, which is 1, plus b squared equals to c squared, and c squared in this case is 25, which is the same thing as 5 squared. And then you solve for b here. So I subtract 1 in this case. So this is 24. And then you take the square root of this. So b in this case is square root of 24, but you have to reduce this fraction, this square root. So again, all your tasks, when you do your my task, if you give me this root 24, you won't get full points. So does anyone know how to do to break it down? What times what is 24?
4 times 6.
Yep, good. And then 4 is a perfect square of 2, so this is 2 root 6. So this is actually 2 root 6. So you can use this triangle to find B, C, and D in this case. So in order for you to do B in this case is cotangent theta. So cotangent theta is the reciprocal of tangent. So if you remember tangent theta is what? Opposite over adjacent. So TOA. So cotangent is adjacent over opposite. So adjacent in this case is 1. And then opposite in this case is 2 over root 6. Now, does anyone remember how you rationalize this kind of rationals expression here?
You have to multiply it by 2
Nope.
square root of 6. No?
Just square root of 6 is enough.
Oh, okay.
Yep, because the 2 is not inside the square root. So you do not need to rationalize that 2. You just need to rationalize to 6. So root 6 will be what we're looking for. So when you multiply this by root 6, which is why, see, I really want you guys to do, try this, and because in the test, then you know what's going on. So, you can still do 2 root 6. It's not wrong. It's just a bit more. So you still get root 6 on top. 1 times root 6 is root 6. Does anyone know what happens when you multiply 2 root 6 times root 6? Don't be shy. I'm not penalizing you guys. If you're wrong, I correct you. If you're right, good for you. Because in the test, you cannot ask me these kind of questions. Now you can. Anyone know how to do this?
It would be 2 times 6.
Yep, 2 times 6, because root 6 times root 6 is 6, so 2 times 6 is 12. So your answer in this case for question B in this case is root 6 over 12. Again, this is 6.2. So if you guys have any questions, we're going to do 6.2 first in your homework. So for those who came in late, if you have any questions with homework 6.2, please ask me now. I will type in the chat room because 17 is one of the questions that some of you asked me. And if you do the watch it, they give you all the weird ways to solve to get this, but I will recommend you to use this way because this is the easiest way to do it. C, cotangent of 90 degrees minus theta. So in order for us to find this, you have to use one of the identity, which is a co-function that I pointed out early on. So a cotangent 90 degrees minus theta is the same thing as tangent theta. Cotangent, they're called the co-functions of complementary angles. They are the same. That means the total of this has to add up to be 90 degrees. So if you want to find the cotangent 90 minus theta, this is the same thing as tangent theta. And using your SOHCAHTOA, tangent is TOA, so it's opposite over adjacent. So by looking at the triangle, again, this triangle is what we're going to do in question 17. Opposite is 2 root 6. And then adjacent in this case is 1 over 1, which is, you don't need to do that. So, so your answer for part C in this case is 2 root 6. You guys all right here with this question? And lastly, D, you use this, you have to find sine theta. So sine is so it's opposite over hypotenuse. Opposite is this one, 2 root 6. And your hypotenuse is 5. And that's it. You cannot reduce this fellow. So this is how we do question 17. So do not, I know when you hit watch it, they use a different way to do it. So I would recommend you to don't, you can do it that way, but this is actually easier to do it because you guys been doing this quite a lot in 6.2. So I would like you to do that way in this case, okay? Anyone have any questions on 6.2?
Or some questions that ask you about to find the pi radians or the degree. Is it okay if I remember the unit circle instead of showing my work?
Like what kind of questions? Like this 22.
Yeah, like find a, yeah, that one.
Like this one. Yeah, you can use a unit circle approach, but so this is very, very important because yeah, I'll do that 10 and 40. Yep, thank you. If I didn't read anything in the chat room, please let me know because I got a lot of things going on in my screen here. So yes, you can use as what Prini says, you can use your unit circle approach, but don't forget in your task, it's not given to you, the unit circle. Okay, so some of you will ask me, like, what is unit circle approach? Unit circle approach, as what Prini mentioned it out, is actually this is a unit circle approach that he mentioned. And again, because in your test you're not allowed to use that, so that's the reason why that you have to draw it your own. Okay, so this is a unit circle approach that that Prini mentioned early on, the one with the circle. So this is the unit circle approach that he mentioned about that. So so some of you guys know the unit circle approach. because this is not, you cannot use this in your test. So that's the reason why that you have to make it your own. So you can use this if you know the unit circle approach. Otherwise, you do the backwards of what you did last time. So what do I mean by backwards of what we did last time here is, for example, is if you have too many windows going on here. And yes, I'll do 10 and 14. Let's say for this kind of questions, you just need to figure out the opposite of this. So if you remember last time for 30 degrees and 45 degrees and 60 degrees, we did this like, this is very important. We got sine, cosine, and tangent, right? So, so does everyone remember what sine 30 degree is? This is very, very important. Sine 30 degree is
pi over 6.
Yeah, I know that is the radian, but I want sine 30 degrees. Is 1/2, right?
Yes.
Yep. What is sine 45 degrees? Is √2/2. And sine 60 degree is √3/2. Another way I call my students to know this is they're all over 2. This is like square root of 1, which is 1. This is square root of 2. This is square root of 3. Do you see that? It's like a, so I always tell my students, this is how I remember this. So sine 30 degrees, 45 and 60, they're all like 1, √2, √3. They all, you put a square root. For cosine, what you do with cosine is you just do this backwards. Backwards means that, so instead of what you do it backwards, so this will be √3/2. So you kind of read it backwards. √2/2, and then 1/2. So you read it backwards of the sine. So this is how usually I remember this, because I remember this when I was in high school. My teacher teach me that. So I just remember it now. And then when I teach, I just tell you guys, this is what I do when I teach you guys, and I just do backwards. Tangent is easy because tangent is cosine over sine. So if you divide the cosine over sine, this one you will get √3 here. Because when you take √3/2 divided by this, the 2 will cancel out, you get √3. And when you divide this, you get exactly 1 because they're the same. And when you divide this, you get 1/√3, which is the same thing as √3/3. So if you know this, so you divide, tangent is cosine over sine. So if you divide them, then, so if you, this one you divide √3/2 divided by 1/2, this 2 will cancel. So what you left is just √3. So that's how we do this start up with, and then you just divide this. So if you got to like question 22, you do the opposite now. Cosine, what is √2/2? So if you look cosine, √2/2, so the answer is going to be 45 degrees. So this is 45 degrees. And radian is pi/4. You guys okay here? If you know this chart that we just did just now, you'll be able to do this. Can someone tell me tangent? What is a theta here that you make tangent theta equals to 1? So if you look at tangent 1, so what angle make him 1? Tangent become what? It's also what?
45.
The same thing as above. So 45 or pi/4. So a lot of students, I will recommend that if you do my test, make sure you do this table first. If you don't want to do the unit circle approach, then I recommend you to use this table, because once you got this table written down in your scratch piece of paper, then you can actually use this to help you, Can someone tell me what is tangent theta is for √3?
30.
30 or pi/6 in radian. So this is 30 or pi/6. You guys all right? Okay. Now, in order for you to do cosecant, like this one, you need cosecant and cotangent. What you need to do now is you have to invert it. So sine is this. So what you do next is you invert the sign. So you will invert, and what is the reciprocal of sine will be cosecant. And then you take all this, you flip it. So 1/2 will become 2. This will become 2 over root 2, which is the same thing as square root of 2. If you rationalize this, this will become 2 over root 3 if you reciprocate it, which is 2 root 3 over 3. Okay, so you take all the sign that you have here and you flip-flop it. And as usual, if you cosine, so in order for you to find the cosine, which is the secant, remember last time how you do cosine, you read backwards of the sign. So what you do here is the same thing. You read backwards of the cosecant. So so you will have 2 root 3 over 3. You read backwards. This one is still root 2. And this one is 2. So for cosecant and secant, you read backwards. And then for cotangent, which is the tangent, you read backwards of the tangent. You go backwards. So this will be root 3 over 3. And then 1. And then root 3. So I put a B next to it, means that you read backwards. You guys know how to read backwards, right? So you read backwards to each other. You guys okay here? Okay. So this is how I do this, and then the rest I think you guys can do the rest of this kind of questions that. So either you do it using this table or you do as what Suk say that you have to do the unit circle approach. All right, what's the next question that you guys have? Number 10 and number 14. So question, this is again 6.2 here. Number 10 is this one. So again, this is all based on this table. Okay, this is all based on this table that we just draw here. So now we want the angle. So cosecant, what angle give us 2? So anyone know cosecant, what angle give us 2? So the answer is
30.
30 or pi over 6. So the degree in this case is 30. The radian in this case is pi over 6. Okay. So mostly all this, the first few questions that you guys did here is reliable on this table that I show it to you. So make sure you guys use this table when you guys do the when you guys especially do the test. Okay. 14. This one you need to use your calculator. Okay, for question 14. Don't forget, you need to know the difference between degrees and radians. If you look at here, be sure your calculator is in the correct mode. So if you have your calculator, take out your calculator now, because if you see the DEG here means you are in degree mode. So if you try to type this out in question 14 in degree mode, your answer is wrong. So you have to change it into radian mode. So for a calculator I have here, you just click on here, you just change RAD. For your calculator, you should have a mode button. And when you press the mode button, you got 3 choices. One is DEG, one is RAD, and one is GRAD. That's gradient. So we don't use gradient. So we just do radian. And then you just type. Now, we don't have cotangent in your calculator, right? We only have, so this especially have cotangent. You only have tangent. So how do we do a cotangent on this case? Is you have to use a 1 over. So if you want to figure out what is cotangent of pi over 18, you have to do 1 over tangent of pi over 18. And the pi has to be the pi symbol in your calculator. You cannot use 3.142. So everyone, please take out your calculator and start typing this down. 1 over by tangent. Make sure it's in radian form. This is again, your calculator is a bit different. Pi. Sorry, this is driving me crazy because of the different calculator. Pi over. Sorry, I told you this is not my So it's pi over 18, because your calculator has nicer. Divided by, then you put tangent on this one. Yep. And then you 1 over here. Ugh, forget about that. I don't like this calculator. So take out your scientific calculator because I don't have. Just make sure it's in degree, in radian mode. That one is horrible. Mode. You guys know how to change your calculator into radian mode?
I looked up a YouTube video.
Oh, yeah. You can do it that way if you want to, but yeah, if you need help with the you just type how do you change your mode to radian using your pi over 18. So it should look something like this. I know you guys can see that. Okay, and then your answer should look 5 point something. Did I got this answer? 5.6 something.
Yes.
And you have how many decimal places I need? 4 decimals, please. 5.6713. Amina, you okay with this one? Marcella, you okay with? Amina, you good? And then the same thing with the question B. So make sure you do the tangent one. So tangent is straightforward. You do not need to do the 1 over. Yep. So make sure you guys, this is one thing that I found out a lot of students make mistakes is they didn't change the mode. Okay. And this is not just used for this, it's in the future also. So just be careful. Okay. Anyone have any questions with 6.2 here? And yes, I think it's recorded. Yep, this is recorded. We'll check again. I do not want to. Good. Anyone have any more questions for me before we go on to 6.3? Okay. So let's talk about 6. If you need, after that, we'll do 6.3. We'll go back to 6.2 if you need questions. Now, 6.3 is special. Why 6.3 is different from 6.2 is because 6.2 is what we call as right triangle. So that means all the triangle in this case is right 90 degrees, okay, between 0 to 90 degrees. So that's why it's a cube. Now in 6.3 is a trigonometric function for any angle. So your angles can be in quadrant 2, can be in quadrant 3, can be quadrant 4, and so on. So how do we do this kind of questions here is you need to know some basic stuff. So I'm going to show you what is the basic stuff here. So, so this is 6.3 now. So the first thing you need to know when you do 6.3, if you want to do the right triangle approach that you guys use here, so how do you draw your triangle if you want to use a right triangle approach is you draw a ribbon. This is how I tell my students, I draw the ribbon. Okay, and the angle theta is either this one if it's in quadrant 1, this one is in quadrant 2, this one is in quadrant 3, and this one is in quadrant 4. Okay, and they always give us a coordinates x, y, because it can be written down as coordinates form. So make sure you know that each coordinates is different in each quadrant, right? So like quadrant 3, both x and y are negative numbers. Okay. So the only thing that you need to watch out here is to find your radius r. Okay. So how do you find your radius r is you use the distance formula, which is the square root of x squared plus y squared. Okay, so and then if you want to find sine theta, so if you concentrate on just this triangle, this triangle that I have, this right triangle, if this is r, and the coordinate here is xy, so that means that this is going up down, so it's going to be a y value, and this is going sideways, it's going to be an x value. So you can use your SOHCAHTOA. So if you remember sine is what over what? Opposite over by hypotenuse. So this is y over r. Okay, and then cosine theta is adjacent over hypotenuse, which is x over r. And then tangent theta in this case is y over x, opposite over adjacent. So this is how they got the formula if you see in 6.3. So when you look at 6.3, the first thing you notice here is this formula pop up, okay? And that for how they got this formula is they use the one that I just showed to you here. They use just any triangle you want, and then after that, the secant, cosecant, cotangent, you just invert it, reciprocal it, okay? So so let's say you want to try to do question number 4 here. So if you want to do question number, I don't know why this keep on minimizing it. Yeah, there you go. So if you want to do question 4, again, this is 6.3. And what's the difference? 6.2, you only do in quadrant 1. But once you hit 6.3, you can do any quadrants you want. So if you look at this, it's given us by the negative root 7 and 1. Negative root 7 is actually your x. So this is your x. This is your, although this is your theta, but your theta is here. And how do I know your triangle looks something like this? Is because this is in quadrant 2. Quadrant 2 triangle is this triangle. Okay, so if they want you to draw using SOHCAHTOA, you want to draw a triangle for quadrant 2, you use that triangle. If you want to draw a triangle for quadrant 3, you have to use this triangle. And if you want to do the triangle for quadrant 4, you use the other one. So it looks like a ribbon, and then you break it down into 4 pieces. They're all right triangles. And then this coordinates will tell us x is negative root 7, and your y in this case is 1. So that's your x and y. So now what you do is you have to figure out your hypotenuse. So you have to use your Pythagorean theorem if you want to, which is the same as this case. This is also Pythagorean. So square of this is 7, plus the square of that is 1, and this is equals to your Pythagorean, your hypotenuse. So you take a square of it, and this is square of 8. And if you reduce this, this is 2 root 2. Okay, and don't forget, this is r. And why we mark this as r? Anyone know what is r symbolized here? Why we give a name r here? It should be named as, start with letter r.
Oh,
Here, if I draw a circle, what we call that?
it's the no, not
it's the
is it
radius.
the radiant.
Is the radius. That's why we call him r, because if you draw a circle, that is your radius. Okay, just that's why we call him r. Okay, so and radius is always positive. You cannot have a negative radius, and you cannot have 0. Your radius cannot be 0. Okay, so your radius is always positive. It's a circle, right? So that's why this number is always a positive number. So this is actually 2 root 2. So now with this triangle, then you can do your sine, cosine, tangent using your SOHCAHTOA. If you forget this formula, don't worry about that. Just use SOHCAHTOA, because your SOHCAHTOA is the same thing. Because you got your triangle already. Okay, but make sure that this x here is a negative. The reason why is because your x value for quadrant 2 is negative. Okay, and your y value is positive. So can someone tell me, by looking at this triangle using SOHCAHTOA, what is your sine theta will be?
Would be 1/2 square root of 2.
And if you rationalize this, you need to multiply this by what? Just the
Square root of 2. Yeah.
Yep. So this is actually is root 2 over by 4, which is 2 times 2. You guys doing all right here so far? The rest, I think you guys can manage to do this one, right? This is not, I mean, again, the problems that you see here, they're all very similar to SOHCAHTOA. That's why they're all, the basic idea here is using SOHCAHTOA. But right now it's any angles you want. So that's why it is a little bit tricky, but still it's the same idea about behind it. Are you guys okay doing 4A by your own here? The rest of it? If I do 4B here, this is 4B. So, so if I want to draw a triangle, because this is in quadrant 4, so your triangle will look like this one, which is this triangle, because in quadrant 4. Okay. And this is the coordinates that give it to us. Can someone tell me what is your x coordinates in this case?
2.
2, and your y coordinates is
-1.
-1. So you need to find your hypotenuse or your radius, they call it r, which is the same as hypotenuse. You use back the same formula you just did to your Pythagorean. So this is 2 square plus 1 square. So 2 is 4, 4 plus 1 is 5, right? Okay. And don't forget, your theta is always inside here. Your theta is not here. A lot of students put theta here. Don't forget, if you put your theta on the other side, it's wrong. Okay, so make sure your theta is always on that origin. You guys see that? Your theta is always comes from the origin, not on the end side of it. Okay, so if you put that, then everything is wrong because you read backwards. You guys all right with this one? I mean, I think you guys know once I get into here, the rest you use SOHCAHTOA to finish it off. Okay, questions with this kind of questions. Same thing happens over here. This one they draw nicely and they give a coordinates. This question 5, they only give you what? The coordinates. So what you do is, so can you tell me what quadrant is this 940 is? If you plot it in your coordinates.
First one?
First quadrant. So it will look something like the one that you guys did in 6.2. And 9 is your x, so your x is always go left, right. And 40 is the one, is your y that go up and down. And since it's the quadrant one, they're all positive. And then you use Pythagorean theorem to figure out what is this one is. I think it's 41. Okay, a squared plus b squared, you guys. And then the rest, pretty much the same thing, SOHCAHTOA. You guys all right here for this kind of questions? I don't care if it's a decimals. First thing first, tell me what quadrant is this belongs to, and then draw the triangle, represent it. Can someone tell me in question 6, what quadrant is this coordinates represent? I know it's decimals, but you can still figure out. Amila, Henry?
Is it 2?
Yep, this is quadrant 2. So quadrant 2 is that orange one. So it looks something like this one. And negative 28.8 is your x. So this is here. And then what? 8.4 is your y. Now this one you have to use a I do not know. You have to use a Pythagorean to figure out what is your hypotenuse is. And then after that, you use your SOHCAHTOA to do the rest. You guys doing all right here so far? Okay. It's not that difficult. It's all based on the same SOHCAHTOA that you guys did in the first few. Now this 7 is a little bit tricky. So in order for us to do the rest of this, this is something you guys need to know, very important, is what quadrant belongs to what. So that's why we do this sign of trigonometric functions. This is also very important. What is this for? Is this is telling us which one is positive and which one is negative. So for quadrant 1, we use A for all. That means all the 6 trigonometric is positive. Quadrant 2, we use the letter S. Some of you learned this in high school, ASTC. All students take calculus, which is one of the, acronym or whatever you call that. So A means all, everyone. S means sine. So sine and cosecant in quadrant 2 will be positive, but the rest of them, cosine, tangent, secant, and cotangent, they all will be negative. In quadrant 3, tangent and cotangent is positive. The rest of this, which is sine and cosine, will be negative. And then in quadrant 4, cosine is positive, secant is positive, and sine and tangent will be negative in quadrant 4. So this is super, super important. Okay. So, so what we do in this case is we have to look at this and then you figure out which one, which one is that. So for like question number 7 is asking us, let me minimize this so you can see. It's asking sine is less than 0. So when you say less than 0 means negative. So when sine is negative, it means it's only quadrant 3 and quadrant 4. So I put a little X on here. Yeah. Okay, so for sine is negative is this 2 because it's positive on that. And then cosine is negative is this 2. Use another color. So can someone tell me which quadrant has 2 axes or 2 colors? And that's your answer. That will be quadrant 3 here. You guys okay here? You guys want to try number 8? And this is so important because this is used in chapter 6. This is used in chapter 7 and chapter 8. Yes, the first 6, 7, 8 chapter. And if you doesn't get this, again, this is all very fundamental, very basic. So secant is greater than 0 means positive. So figure out which quadrant will fulfill these 2 conditions. Is that 1, 2, 3, or 4? Anyone knows?
4.
4. Agree? Anyone? So in order for us to do this, we can look at the quadrant. So secant is positive means either is quadrant 1 or quadrant 4 because secant and cosine is the reciprocal. And cotangent is negative. Cotangent is tangent. So I'm going to change color here. So it will be negative means it's either quadrant 2 or quadrant 4. Oops, sorry. So now you find out that quadrant 4 has 2 x or 2 so quadrant 4 will be the answer in this case. You guys all right here? What is this used for? Because once we know it is in quadrant 4, then your triangle will look something like this. Then you use your SOHCAHTOA. And once you know it's quadrant 2, then your triangle will look something like this. So that's the reason why that on the rest of the few examples after that, they don't tell you what quadrant it belongs to because they don't give you a coordinates. Like here, they give you coordinates, you can figure out the quadrant quite easy. But like this question, they don't tell us the coordinates, so you doesn't know what quadrant it belongs to. So how do you figure out this? Is again, we use the same thing that you just did over here. So the first thing you find out here, like this question number 9 here, before you do this, you have to draw the triangles and do the SOHCAHTOA. Cosine is positive, so cosine is positive is quadrant 1 and quadrant 4. And then you tell us tangent is negative. Tangent negative is quadrant 2 and quadrant 4. So this telling us that this theta is in quadrant 4 by looking at the condition. This is positive and this is negative. And once it is, this will give us quadrant 4 like what we just did just now. And once we know this is in quadrant 4, then your triangles will look something like quadrant 4 triangle, which is a red one. So this is for question 9. So this is quadrant 4. This one. This is in quadrant 4. And then you can use your SOHCAHTOA to do it. So cosine is 35 over 37. Cosine is adjacent, right? Adjacent over by hypotenuse. So 35 is your adjacent, hypotenuse is 37. So you need to use your Pythagorean theorem to find your opposite. So how do we find your opposite in this case? This is a big number. 35 square. What's 35 square? 35. Yeah, calculator. And if you know the triplets, good. I think it's 7 or 9. 35 square is 1,225 plus b square equals to 37 square is 1,369. So this is again, if you doesn't know your triplets. So you subtract from 1,225. So you get 144, it's actually 12. So B in this case is actually 12. But class, this is something I want you guys to pay attention because this is the most common mistake students do wrong in the test. If you give me 12, this is wrong. But yeah, 144, right? Square root of 144 is 12, right? So can someone tell me why 12 is wrong? This is the most important stuff that, I mean, you guys know how to do the rest, but. So can someone tell me why 12 is wrong? This is the most important thing that a lot of students do wrong in my test is this one. If you can pick it up, good. If you don't pick it up, listen up. Anyone? Let me ask you guys.
It's in quadrant 4, so it should be negative, right?
Thank you so much. That is the reason why this is wrong, is because this is supposed to be negative 12. Yes, this is correct. So be careful with your value here, because in quadrant 4, your y value is negative. So that's why this should be a negative 12. And then the rest is easy, right? Then you apply SOHCAHTOA here to do the rest of this question. So this is why a lot of students do wrong in my test. So just want to point out to you guys, those who are, for quadrant 1, everything is positive. In quadrant 2, your x is negative, your y is positive. In quadrant 3, both x and y are negative. Quadrant 4, your x is positive, but your y is negative. So that's the reason why this answer is a negative 12, not 12. And then with that, your whole thing is wrong. Your answer is correct, but your sign is all mixed up. Questions? Questions?
Can you go over question 13?
So I'm gonna go with question 13 now. Good. Yep, that's the next one I need to go through. You guys all right here so far? Now, I just need to do draw the pictures of question 13. I think the rest of them you can apply SOHCAHTOA, just drawing the picture. So question 13 is a bit special, is because they were asking us, oh my God, come on. Okay. Okay. They usually don't have that. So in question 13, they will say it's already in quadrant 3. So we know that the triangle, it looks something like this. This is a triangle for quadrant 3. But they don't give us they give us any value. They give us a line. So imagine that this line is y equals to 1/4 x. This is the line given is 1/4 x. So my question to you here is that we need to get a coordinates on this line. Any coordinates on this line in quadrant 3 will work. So now, can someone tell me what value can we put in for x to plug in here so we can figure out? Now, you cannot use 1, 2, 3, 4, 5, 6. You cannot use all this number because those numbers are positive numbers. Because since it's in quadrant 3, your x has to be what number? Your x has to be what? Negative number. So you have to substitute a number here that belongs to this range or this domain. And I will use -4. And the reason why I use -4 is because I don't like fraction. So once I plug x become -4 in here, what is y in this case? What's 1/4 times -4? That will become -1. So now we got your coordinates here. Your x in this case will be -4. And your y is -1. You can use any number you want, like -3 or -1 or -2. But if you use those numbers, you end up with a y of being a fraction. And you do not want to play with fractions, right? I think you guys hate fractions. I mean, one doesn't like fractions. So that's why I use -4 here. And the reason why you have to use negative, you cannot use positive number, is because it is in quadrant 3. You guys okay here? So can someone tell me what is your hypotenuse in this case for question 13? Anyone? 4 squared is 16. 16 plus 1, that is what? Square root of
17.
17. And the good thing is because your hypotenuse is always positive, you do not worry about negative positive. So question 13, this is your triangles you're going to use. And then you apply SOHCAHTOA to find the rest of it. You guys all right here? I think once I draw this triangle, I think you guys know how to apply this one, right? To do the rest of this. Oh my God, it's driving me crazy. I don't know why they do that. They not used to do that. This is all new this semester. I don't know why they do that. Oh my God. Ah, sorry. I will tell to the Sandwich people saying that do not do that. Why they lock me out automatically? Henry, are you okay with question number 14? So 14 or 13?
Yeah, it makes a lot more sense.
Yep.
It makes more sense once you like draw the triangle, just so you can like visualize it.
Yep. So again, again, it's quadrant 3. So a lot of students pick the positive numbers. That's why it's wrong. Anyone have any questions? 9, 4. Yep, we did that. Evaluate the triangle and quadrant. Okay. So this is one thing I want to point out with the undefined cases. Okay. So this is your sine, right? And then we do the reciprocal of this. So sine a cosecant, you flip it, is r over y. And then secant is r over x. And then cotangent is x over y. So this is the formula that we use for if you use your SOHCAHTOA, this is how they do it. As you guys know that your denominator cannot be 0, right? Because when you divide, your denominator cannot be 0, right? So as you guys remember, your r, your radius, cannot be 0. So your sine and your cosine is always a defined case. Defined case means that you always have a number for it. But for tangent, cosecant, secant, and cotangent, there are certain values that you will get undefined case. And how do we know we get undefined case? For tangent and secant, because your denominator is x, that means your x here cannot be 0. See that x? So what happens if your x is exactly 0? So does anyone know what happens if your x is 0? For example, where is the coordinate 0, 7? Or 0, -3? Or 0, 5? Where is this located at in the xy values, in the graphs coordinate system? Where's 0, 7 located at? Right here, right? And 0, -3 is right here, right? So this is all your x value is being 0. Does anyone remember what angle, if you draw an angle, what angle is this angle is? This is 0. This is how many degrees? This is 180, right?
90.
90. And then what's the other one down here? 270, right? So what happens in this case that when you want to find tangent 90 degrees or secant 270 degrees, this is undefined. The reason why this is undefined is because your x value will become 0. And anything divided by 0 is undefined. Can someone tell me what is this in radian? 90 is pi over 2. And 270 is
3 pi over 2. Yep.
So can someone tell me what happens if you want to find secant 3 pi over 2? Yeah, where's my mouse? So secant 3 pi over 2 is what? It's actually is undefined. So this is actually is undefined. You guys with me here? Now this is for tangent and secant because your x is 0. So it's undefined. Now we will talk about cosecant and cotangent. This is where your y value is 0. Because we cannot have 0 in there, right? But what makes it 0? Think about your coordinates. That means all your y value is 0, like 7, 0, negative 5, 0. Where was this located at if you look at your graph? 7, 0 is somewhere here, right? And negative 5, 0 is somewhere there, right? So what is that belongs to in angle? It's between 0 or what? 180 or 360 degrees. So if you want to find cosecant of 0 degrees, or if you want to find a cotangent 180 degrees, this is going to be what? Undefined also. The reason why is because your y value is 0. Okay, so this is for the undefined special case, and if you forget this, don't worry about that, because in tomorrow's class we will graph this 6 trigonometric functions. Start with sine and cosine first, and then we do tangent, secant, cosecant, cotangent. And if you forget about that, the graph will point out to you where is the undefined case. And for the graph, if it's an undefined case, you will draw what we call as a vertical asymptote. You guys remember asymptotes back in college algebra? So a vertical asymptote means it's like this. Okay, so if you want to draw a tangent graph, let's say this is tangent, at 90 degrees, you will have a vertical asymptote. And then at 270 degrees, it will have a vertical asymptote. At negative 90 degrees, you will have a vertical asymptote. And all this vertical asymptote is telling us it is undefined on such value. So if you cannot remember this, which sometimes I forget, and the only thing I remember this is I have to draw all these pictures I showed you. X is 0, Y is 0, and then put it in the coordinates point, and then figure out is at 0 or 90 degrees or 270 or something else. But if I look at the graph will actually point out, and every vertical asymptote you draw, that is where the value is undefined. Okay, that is the way again, you will learn this in tomorrow's class. You guys all right here so far? So can someone tell me what is cotangent 0 is? Cotangent 0, number 18. So cotangent, your y, 0 is right here, right? So what is cotangent 0? It's also what? Undefined. Have to be caps. Don't forget, if you put this in a lowercase, they will mark you wrong. You guys all right here? So that's the reason why that when you guys, where's my little friend? Sorry, a lot of windows opening. So this is one of the things you found in D2R, right? And then the other thing you also have in D2R is the exact value. And this exact value, you will see this little UND. This UND means it's undefined. So I know it's going the other way around. Sorry about that. But if you print out, it'd be nice. So if you look at this question, if you ask for cosecant pi, so if you have this table with you, like number 19, cosecant pi. So cosecant pi is 180. This is cosecant, right? This is 180. Cosecant is this one. This is 180. So cosecant, what is cosecant pi or 180? Your answer is
Undefined.
undefined. Yep. So this is how you read this table. If you got this table with you, so this will be undefined too. So you can print it out too if you want to. And again, one more time, cotangent pi over 2. So again, if you have this table, pi over 2 is 90 degrees, right? And what is cotangent for that case? Cotangent 90 degrees of pi over 2 is
0.
0. Yep, the answer here will be 0. You guys okay here? I'm trying to, I mean, if you are in face-to-face in my class, you will learn this like every day. I will like hammering you guys like crazy. Questions? Yeah, this is very important. And this theta that we do here, this 4 theta, is what we call as a reference angle. Okay, so we call this theta as reference angle. So 277, does anyone know where is 277 if you draw this in an angle? This is 90, this is 180, this is 270, and then 277 is just right here, right? And the theta that we need to find is right here. This is the theta. So this is the theta we're looking for. So can someone tell me what is this theta? And this theta is called a reference angle. You guys know how to find this brown color angle? 360 subtract by 277, right? So it's around like 83. Right? Okay. So your answer will look like this one because it will, that's the one that we just draw here. Right? This is 277, and then this is the 83 that you draw and that we found. You guys all right here with this? Radians is a little bit different. 5 pi over 4. So how do we do 5 pi over 4 in this case? I need to start a new one. And yep. So 5 pi over 4. So from here to here is pi. And if you do 5 pi over 4, 5 pi over 4 is a tad bit more. So this is 5 pi over 4. Because here is 4 pi over 4, which is exactly the same thing as pi, which is 180 degrees. So can someone tell me what is this reference angle, the orange one? If this is 4 pi over 4, this is 5 pi over 4, then this is, what's the difference between these two numbers?
1 pi.
Or pi over 4, yep. That's your answer in this case. That's your reference angle. Okay, so if you look at, if I teach you this, it's very easy. So pay attention. If you are in radian, your radian, if I give you 7 pi over 6, what is the reference angle? It's pi over 6. Because it's over 6, so it's pi over 6. If it's 3 pi over 4, what is the reference angle? The reference angle will be what? Pi over 4. So I can tell you that if you guys are doing the reference angle for a radian piece, I mean, the drawing's helpful, but if you want to do it quick like this, I will just tell you, hey, this is over 6, pi over 6. Okay, so like, yeah. So that's what I can tell you for this case. Let me do one more, which is.
Excuse me.
I'm sorry, Faris.
Yeah, it won't let me log in. It keeps saying
we'll talk about that after class.
Okay.
Okay. Yep. Calculators again, class, when you do this kind of questions, again, watch out for degree. And if you don't see the little degree sign, this is in what form or what mode?
Radian.
Radian. So be careful with these two kind of questions. And if you don't have, your calculator do not have secant, so you have to do 1 over cosine. Okay, so make sure you do that. This is back. If you want to know how to do this kind of questions again, you can use the table, or you can use the unit circle that someone mentioned. So how do you use this table if you want to do this? So sine theta is √2/2. So what you do in this case is, if you look at the table for sine theta, let me just put it up here so you guys can see both of them. So sine theta is here. So can you tell me, this is sine theta, the whole thing, right? I know it's doing upside down. Can you tell me which one of these give us √2/2 positive? This one, which is what?
45.
45. What else?
The radians is
this one too. No, 2.
135.
135. Anything else? No. So your answer is 45 and 135. So you got 2 answers in this case, because sine is positive in quadrant 1 and in quadrant 2. So that's why you got 2 answers in this case. And then this one, you just tell me the radian. This is pi/4. And then the other one is 3 pi/4. That's from this table. You guys okay here?
Is this 6.3?
This 6.3, yes.
Okay.
Let's do secant theta equals 2. So secant is this one. This is secant. So for 2 is this number, right? Secant theta 2 is him. And secant theta 2 is also him. So again, because this is, I don't know if I can do this upside down. No. I'm sorry, it's upside down. So secant 2 is this one. So if you go, this is 60 degrees. And then the other one is 300. So secant 2 is 300. And then 2 is, so 60 and 2. And why you got 2 answers? Because secant is cosine. Can someone tell me cosine is positive in what quadrant? Quadrant 1.
And 4.
And 4. And 300 is quadrant 4. And then you figure out what is the radian. You can do that. You guys all right? So a lot of students say that, is this table important? Yes, if you want to use that table. Where's my table? So yes, if you want to use this table, it's a lot, right? Look at that, it's very, and some of you say, how about the unit circle approach? So this is what the unit circle approach, those students who doesn't know the unit circle approach, this one. Okay, so how do we use this unit circle approach if you guys doesn't want this? It's easy enough. So so we do 30 degrees first, which is the pi/6 over here. If you can see 30 degrees, 30 degrees is pi/6 here. So what you notice here is, if you look at this 30 degrees pi/6, we will have a coordinates. And this coordinates is √3/2 and 1/2. Okay, so so this, if you point out this coordinate right over here on the 1, this is √3. How I get √3/2 and 1/2 is because if you do a 30 degrees, these measurements, this is a 30 degrees measurement here. And if you draw another 30 degrees measurement, this is an equilateral triangles. And this, you draw, this is all going to be measurements of 2, 2, and 2. And if you break this into half, it's 1 and 1. So this is actually √3/2. And if you look at your coordinates, this is √3/2 and 1/2. And that is for 30. And if you do 45 degrees, green. No, still, I got a lot of stuff. So if you do a 45 degrees, this 45 degrees, the coordinate is √2/2 and √2/2. And then if you do the 60 degrees, this coordinates is going to be reverse 1/2 and √3/2. It's a totally flip on this. What is going on here is that, as you guys remember, that sine is y over x r. And since the radius is all 1, so the r is redundant. So sine theta in this case is y, and cosine theta in this case is x. So if you look at all this value for x, this is for cosine. So if I ask you what is cosine 60 degrees, your answer is, oh, wait for a minute. Yeah, it's 1/2, sorry. Is that correct? Yeah, sorry. Yeah, cosine 60 is 1/2. Yep. And if I want you to find, and then the good news is if you go to the other quadrant, so when you do 60 degrees, it'll be 120. So you take these coordinates and you make it negative on the x and positive on the y. Because on the quadrant 2, x is all negative. And then if you look at the 45, which is √2/2 and √2/2, so this will become negative √2/2 and √2/2. And what is 45 on this side is 180 minus 45, which is 135. And then, so which is this one. Okay. So if I can save this, sorry. And I'll open it up. So make it nicer for you guys. I don't want to look at this. Oh, it's HTML. So if you have this, you can write this like that. And then the last one is 30 degrees. So 30 degrees is going to be correspond to 150, which is this fellow. And the coordinates is exactly the same as this fellow, but your x value is negative. And what I'm teaching you here is what we call as a unit circle approach. So some of you use this, and some of you learn this in your high school. So this whole triangle is the same as that table that I showed to you, but it's in a circle. It's a more nicely formed, so it's not as the table that you guys give me a look at what's going on with that. Okay. And same thing happens with the rest of this. So they all will have in different quadrants. So this two will be negative. This one will be positive on quadrant in x value and negative on the y value. So a lot of you use this table to figure this one out. Okay. So that's how we use the unit circle approach to figure your work here. Let me show it to you here so you guys can see it. Some of you might not be able. Sorry. Where was it? It's a lot of. So you guys can see better here. So on 30 degrees, this one will be square root of 3 over 2 and 1/2. That is the coordinates. Okay. And anything that is correspond to 30 degrees means it's over 6. We use back exactly the same, but the sign is different. So for quadrant 2, this is negative square root of 3 over 2 and 1/2. And then for so 30, 150, and 210, it's all the same. I'm going to copy and paste this. Is it copy and pasteable? Oh. Negative square root of 3 over 2. But this is negative 1/2 because quadrant 3, both of them are negative. And then this one is square root of 3 with a negative 1/2. You guys okay here with? This is all correspond to 30 degrees. Okay. And now I'm going to correspond to 45 degrees. They all are square root over 2 for both of them. Square root over 2, sorry, square root over 2 over 2. On both x and y. Okay, and this is exactly the same as that one, but you put a negative on the x value because in quadrant 2 this is negative. This is also the same, square root over 2, but both of these will be negative because quadrant 3 both values negative, and this one is also the same, but the y value is negative. You guys all right here? Put this in orange because that belongs to orange. You guys questions so far with this?
Yeah, and like what exactly are those?
I will show it to you later on.
Okay.
Okay. Those are coordinates, x and y.
Okay.
Those are coordinates, x and y. And the last one we have is, I'm gonna use black. It's 60 degrees. So this one is the opposite of him. So this is 1/2 and square root of 3 over 2. And those who are opposite with 60 will be 120, which is the same as 1/2. But then your x value will be negative. And then this one, both of them is negative. So those people who like the unit circle approach, this is what is going on. This one is negative, and then I'll show you what this looks like. Now, we don't care about 15, we don't care about 75, 105. These are all, we don't care. The 1 over 12. Anything that's over 12, we don't care. Because we don't do that. Okay. And then we can do the 0, 360. Those are easy because 0, what is the coordinates of the 0 is going to be 1, 0. Why is 1, 0? Is because if you have this, your radius is 1. But as you know that your y value, you don't go up and down. Same thing with 90 degrees is 0, 1. 180 is negative 1, 0. Because it's on the negative side. And then 270 is 0, negative 1. Because it go down to the y value. Now, why some of you do this? Once you know all these coordinates, then you can apply your sign. Because sine theta is y. Cosine theta is x. Tangent theta is cosine over sine, which is x over y. Sine or cosine. With a tangent is sine over cosine. Uh-oh. Sorry. Tangent is sine over cosine. Yep. Oh, sine over cosine. So sine over cosine is y over x. Sorry. So what you do here is this theta is all these angles. And then this is xy. And then the flip-flop for this, after you know the flip-flop. So if I ask you to do what is sine 180 degrees. So 180 degrees, this one, right? Sine is your y value. So what is the y value on these coordinates?
0.
0. That's your answer. Secant 210 degrees. So 210 is this one. Okay. Secant is the reciprocal of cosine, right? Which is 1 over x. And x, what's the x value for this case? Negative
1.
No, this one. So x is this value. So it's negative square root over 3 over 2. But you have to put 1 over it. Or you flip-flop it. Negative 2 over root 3. Which is the same as negative 2 root 3 over 3. So what is secant 2tan? Negative 2 square root of 3 over 3. Oh, if you want, you can use that table I showed it to you early on. Remember that table that I have, the Iki table that you table. Yep. And you will get back the same thing, secant 2tan. So 2tan is this one, and secant is this one. You get negative 2 root 3 over 3. See that? Which is the same as the one that we just did on this unit circle. So that's the reason why that some students asking me this, can I use a unit circle? Yes, you can. Can you use? Yes, you can. Doesn't matter because your answer is still going to be the same. But a lot of who like to visualize, this is a good for visualize, and they know undefined. They can do undefined too. Like tangent 270. Tangent 270. 270 is this one, right? And tangent is what? Y over x. And what is y value in this case? Negative 1 over
0.
0. And what happens when you have negative 1 over 0? This is undefined.
Wait, can I take a picture of that unit circle real quick?
Yeah, I will post this in D2.
Oh, okay. Never mind. If you post that in, it's cool.
Yeah. Yep, I know, Henry. Yep. You guys okay with this one? So a lot of students use this, and if you start with this, the rest, you see the orange, you just need to change the negative sign based on the coordinates. And then this is for 45, and this one is for 60. And this represents the same as this table that you see here. You don't like this table. I don't think so. A lot of people like this table, but this is a one way to do it. But unfortunately, you are not allowed to able to use this in your test, as I mentioned, right? You cannot. So you actually have to make your own. And this is important. Let me give you one more, and then we'll end today's class. Secant, let's say 7 pi over 4. Yeah, I will post this in D2L, so you know what to do. You will refer it. It's under others. So 7 pi over 4 is here, right? Secant is reciprocal of cosine, right? Which is 1 over x. And what is x in this case? X is this one, right? Square root 2 over 2, sorry. So x in this case is root 2 over 2. But you will have is secant, so you flip it, so it's become 2 over root 2, because this is secant. And then if you rationalize this is root 2. So your answer for this case will be square root of 2. You guys you want to practice what? I did a lot of work, so why you guys want to practice one? Using this unit circle approach? Okay, I'll give you one and you do it yourself, okay? Let's do tangent 330 degrees. This is 330. And the formula for tangent is y over x. So 330 is right here. Yes, this will be posted in D2L. And then after that, I'll do another example in your homework using this unit circle approach. Then you figure out, oh my God, this is actually, yeah, a lot of students like this. I like this a lot because it's not too difficult. probably going to spend like 2 minutes in your test to just create this circle. Now I'm going to put this on the side so you guys can. So anyone know how to do tangent 330? Which is y over x. What is y value for 330? 330, your y value is what? Negative 1/2. Put in a fraction, don't change the decimals. And x in this case is √3 over 2. Now you rationalize this, you simplify this. So 2 and 2 can cancel out. So what you get?
Negative square root of 3.
Over by 3. Because you,
yes.
Yep, and that is your answer. So what is tangent 330 is negative √3 over 3. This is your answer in this case. Yep. Questions? Okay. Now we can use this unit circle approach to do your homework. Yes, we can do your homework here. So your homework in 6.3 at the end is asking us here, like a few of them. Use a unit circle approach to do pi over 3. Pi over 3, if you refer to this, pi over 3 is this one, right? This is pi over 3. What is the coordinates of pi over 3? Is 1/2 and square of 3 over 2. So that is the coordinates. So for that, coordinates here is 1/2, comma, and then square root of 3 over 2. So that is the, this table that. Okay. And then next, they want you to, sine. Sine is what value? X value or the Y value? And I always remember this, my students, my teacher, sine is X or Y? Y, yeah, like S-I-N-G, sing. My high school teacher always tell me, like sine is like sing, S-I-N-G, but instead of G is Y. So the Y value, so what's the Y value in this case? √3 over 2. And cosine will be your
X.
Yep, 1/2. So if you know these coordinates, you should know this. And we didn't use SOHCAHTOA to do this. Yes, you can use SOHCAHTOA to do this, but this is even quicker than SOHCAHTOA. And then tangent, you take sine over cosine. In this case, it will be square root over 3. You guys all right? Because it's sine over cosine, so the 2 will cancel out, so it's √3. That's your answer. And then same thing happens with pi over 4. You just need to look at this circle. Pi over 4 at the coordinates is √2 over 2, √2 over 2.
Wait, how did the 2 cancel out?
When you divide.
Okay.
So when you divide these two, the 2 will cancel out because they have both of them having the same denominator. So every time when you divide something like this, see that if they are the same in the denominator, they will cancel.
Okay.
Yep. And then what you left is just negative 1 over √3. And then you rationalize and become that. Then you multiply by √3. Then you end up with that. So every time, that's the reason why we want to keep your denominator all the same number here, because then you can cancel them easily. Because you can cancel out like that. Questions you guys have? So yes, I will post like 7 pi over 3. You just need to look at 7 pi over 3. Where was it at? Right over, where was 7 pi over 3? Should be one of these. Over 4 pi. Oh, no 7 pi over 3. So you have to go circles around. Yep, I know, Sally. Yep. I'll end this. So so in order to do 7 pi over 3, this is pi over 3. This is where's the other one? 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, So 7 pi over 3 is back to 60. So 7 pi over 3 is actually exactly 60 degrees. So some of you who do that way, you can go circle, 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 circle on this. So 7 pi
Wait,
over 3
what is that exactly? Like the thing that you were counting right now?
It's the radian measurements, because 7 pi over, they figure out where is 7 pi over 3, right?
Okay.
And if you look at this circle, you don't have 7 pi over 3. So what you do is this is pi over 3, 60 degrees.
Mm-hmm.
Then this is 2 pi over 3, 60 plus 60, 120. Mm-hmm. And then you add 60. This is 3 pi over 3.
Mm-hmm.
And then you add another 64 pi over 3. And then add another 65 pi over 3. Add another 66 pi over 3.
Mm-hmm.
And then 7 pi over 3 is right here.
Okay.
So you back, so 7 pi over 3 is the same thing as pi over 3.
Okay.
You just go one full circle.
Okay, for example, if it was 8 pi over 3, then it would be...
Then you add another, so it's right here.
Okay.
And then 9 pi over 3 is here. 10 pi over 3. So you keep on, so anything, like if I want you to figure out where is, let's say, negative 11 pi over 6. Or let's say, negative 17 pi over 6.
Mm-hmm.
So don't forget, now you go backwards. This is over 6, negative, this is negative 1. This is negative 2. Yeah, see, this is 6, right? See the 6? Mm-hmm. Negative 1, negative 2. No. Sorry. Negative 1. Okay, you count, sorry. This is 2, right?
Right.
Negative 1, then you count 2. This is negative 2. Negative 3. Negative 4. Negative 5. Negative 6. Negative
Why are we only
7.
going 2?
Huh?
Why are we only going 2 points?
Because when you go 6 is 30 degrees. Mm-hmm. By looking at this, 30 degrees is count 2. See that?
Oh, okay,
45 is count 3, and 60 is count 4. You see that?
And 1 counts 15, correct?
1 count 15, yes.
Okay.
But so 1 count 15, but it's negative, so we have to go clockwise.
Okay.
So so in this case, you have to do how many? Let's see, how many you got?
17.
17. So you have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. So it's right here.
Okay.
So you have to count because it's negative.
Okay.
So yeah, so make sure, so that's why this circle is so important. And unfortunately, you cannot use this circle in your test.
Right.
But you can actually print out the blank one, and then you can fill it in the test. I'm fine with it.
Okay.
So you can actually fill in, the blank one is also in D2L. So I will put under here. So this one, the units, this is the blank one. You can actually print this one out because it's nothing, it's clean.
Mm-hmm.
And then you can write whatever you want during the test time, and then you can use this for your test.
Okay.
Like what I just did over here.
Okay. And this one will also be on D2L, correct?
Yeah, I will put this in D2L. I write on the same thing, but I will say with coordinates.
Okay.
So you will see all these coordinates pop up.
Okay.
Yep. All right. That's it for today's. We still have meetings tomorrow. This is just, extra, and so I didn't take any attendance and anything. So this is extra for you guys. So tomorrow we start graphing this these trigonometric functions for tomorrow class. So that one I will take attendance and so on. Faris, do you have any questions? Marcella, you got questions for me? You've been quiet since.
Okay, so I have a question.
Go for it.
Okay, so I tried logging into WebSign, but it's not letting me. It said, whoops, you're seeing this means our web server is experiencing technical issue. The problem is not with your computer or internet connection. Please try again later or try going to your dashboard. If you continue to experience technical issues.
Can you share the screen for me? Let me just, I'll make Jeff co-host first, and then I'm going to stop sharing. Can you share the screen for me, please?
Yes,
so this is not the homework. This is mostly this is what you get. Can you first, can you log out and then re-log in back again?
Oh yeah, I'll try.
Yeah, do it. You got your thing saved, right?
Mm-hmm.
Yep. Mm-hmm. I think it's something wrong. I think you might, what happens in your computer is if you're not active, you're idle, you're not active for like 10 minutes, they will automatically kick you out.
Oh, okay.
So you have to,
I
like
see.
what I just told you, you have to log out and then, yep, click on which is the one.
Which one?
The homework. Yep, that one. Click on that one. Where's your homework here? Yep, click on it.
It says access ends today.
Yeah, that ends today. So have you buy the book yet? Or have you bought the access code yet?
I haven't bought the book, no.
Yeah, you have to purchase the book or the access code in this case.
Okay. Where do I buy the book from?
Bookstore.
Okay.
Or you buy it from here for $100.
Okay. Do
If
you have
buy
any
it from
idea it costs in the bookstore?
I think it's more than that because it comes with the book like 140, 150. You should buy this in the first day of class already.
Okay, yeah, I'll get it.
You need the book to do this. So if you buy it from the bookstore right now, you're gonna wait for another week.
Okay.
So it's gonna cost you, if you scroll down a little bit, it's cost you $120, looks like. The unlimited, or $100 for the digital platform. So it's either one of those if you buy it on Cengage, and it does not take financial aid. So you have to use your credit cards and debit cards to do it.
Okay.
But if
so when I buy it, what would I do? Like, do I get a code inside it?
if you buy it from the website, automatically you don't need a code. They will automatically do that for you, and then you get into the class. But if you buy it from the bookstore, you have to wait for a week for them to deliver it to you, and then after that, it comes with the code. You have to enter the code by yourself.
Okay. And everyone has the same code, right? It's just the same code in the book.
No, everyone has a different code. The code is just to register. The code is to register to my class.
Okay.
The access code is different. It's like the code is very unique it's only one of a kind.
Okay. Okay.
Yep. The course ID that I give to you in the first day of class, that is just to tell you that you're registering to my class. That is my class ID, not the access code.
Okay, so I won't be able to do the homework until I buy the book.
Oh yeah, until you either buy the book from the bookstore or you buy it from here. So if you do this is only good for 4 months. Can you go for the digital platform from $100? Can you click on that one and see what you got?
Where is the digital platform?
Next to the unlimited on the top. You see the digital platform pop up. There you go. So this one is just only for the book.
Okay, so why does it say 5 months?
It's only good for 5 months.
Okay.
And if you go to the Cengage, back to the Cengage Unlimited, that one is good for 4 months.
Okay, and after 4 months, what happens?
You're done. Then that's it.
Oh, so it's basically like I pay $100 for a subscription, basically.
Yes, like your Netflix or anything. But however, if you do the Cengage Unlimited, this $120, if you have other classes that is using Cengage, like your business or your chemistry, then if you buy this, it's good for all classes for 4 months.
Okay.
So do you use any Cengage product?
No, I only use it for your class.
Then I would recommend you to just buy save $20 and buy that $100, the digital platform, because then it's just for my class. But let's say if you do like English and chemistry, they're all using this Cengage product, then you just buy this, and it's good for all the classes. That means you do not need to buy 6-7 different codes. You just buy one code, and this code is good for all the classes.
Okay. Do you have any idea how much it costs in the bookstore? Like, is it cheaper or?
No, it's more than that.
Oh.
It's like $140, $150. Go to yep. So, but the bookstore, if you're under financial aid, then it will count.
Okay.
So make sure you this is serious. So can you still is expired already or still running?
Let's see. Where do we go?
Go to students. I think you are in a different is that my
I'll look it up again right here.
Yeah, you just go back to your there you go, that's the right one. So yeah, it's access expired. You see the access? Yep.
Yeah.
It's expired on the 25th, which is today. Can you click on that one? Yep. So it's expired. Yours is expired already. So that's how you do. If you buy the book from the bookstore, do you see the enter access code? That's where the access code came in, and you have to enter right over there.
Okay.
Otherwise, the $100 is you buy it from the website, and they will, they will do it for you.
All right, that's my only thing. Okay, I'm gonna buy the book today probably, but if I'm gonna start doing my homework today. If I have any questions, is there any possible chance that I can like
ask me? Yes.
Like get in a Zoom call with you or something tomorrow?
No, you just email me.
Okay, just email you.
Just how you do this is I'll show it to you. Can you unshare your screen?
Yeah. I'm trying to figure out how to do that.
I'll do it. It's fine.
Okay.
I'll do it for you. You got my screen now? You see my screen?
Yeah, I'm looking at your screen.
So let's say this is the homework that you're doing. See, this, let's say you doesn't know how to do this question. Just click ask your teacher.
Okay.
And then you just type whatever you want. I need help. Then send it to me.
Get an email?
I'll get an email.
And then you would respond back to me through the email or through here?
Through here.
Okay.
So when I respond back, it's not through the school email or your Yahoo, whatever email that you put in, it's going to be through this. You have to go back to WebAssign. And mostly some books have like watch it.
Yeah.
I don't know you noticed that or not.
Yeah, I already know that. I already used it before.
Okay, good, perfect. Yep. So this is the ask a teacher is the one that you just send me an email and then I'll.
Okay.
And if you need any questions, it's just ask me. And then you can also ask for extension, right? On the way top there. I don't know if you know that or not. So the very top of the sections, you can request extension right here.
Okay.
So I don't know what questions. I'm gonna take Marcella out. Marcella, are you there? Marcella, I'm gonna kick you out. Oh, she's replying. Yep. Okay. Okay. I'm gonna stop. Oh, I'm still okay. I'm gonna stop recording here. Shoot. Stop.